Welcome, class. Welcome to Investigation 2. We'll be covering 2.1 today, but Investigation 2 is going to be covering changing area and changing perimeter. Before we move forward, I just wanted to make sure that everybody understood Investigation 1, and that involved area and perimeter. The area involves the space inside the figure, and perimeter the distance around the figure. These are things that you need to know moving into Investigation 2, so that's why I'm covering it, just as a reminder. So this is going to be the perimeter going around the figure, as you see here, and so that would be the perimeter, and this is the area going to be inside of this rectangle or any kind of figure it is. And this figure, when I say figure, right now we're dealing with rectangles. It doesn't have to be a rectangle. It could be a triangle, it could be a circle. We won't be covering circles at all this year, but just so you know, when it covers area and perimeter, it's meaning the perimeter is outside and the area is inside. Now, just to show you how to find the area, it's going to be length times width. So this is the length, and this is the width. Another important term to know, when you communicate things about math especially, this is important information to know. So length times width, I'll be doing 12 inches times 6 inches. So 6 times 2 is going to be 12, carry to 1. 6 times 1 is 6 plus 1 is 72. So our area here is going to be 72 inches squared. Now, it's very important to make sure you understand that area always has a squared in it, whatever the unit squared. Now the perimeter, the way to add up the perimeter is going to come to 12 plus 6, which is 18, plus 12 on this side also, and plus 6. So that's going to come to 36. Perimeter is going to be equal to 36. And you add everything up. Just to make sure, this is just a refresher, so you can remember what to do. It is important before we move into Investigation 2. Alright, now changing area and changing perimeter is the introduction to all of Investigation 2. We are just going to be covering fixed areas, today, but we'll be eventually going to a fixed perimeter in the future. So we're probably wondering what a fixed area is. Well, I'm just going to read this. This investigation explores these two kinds of problems. You will find the maximum and minimum perimeter for a fixed area. You will also find maximum and minimum area for a fixed perimeter. Fixed area or perimeter means that the measurement is given and does not change. So we're going to be covering the fixed area, which fixed area means that it will not change. Now, just to cover some goals where we're going to be going with this lesson is we're going to explore questions of maximum and minimum in the context of finding the largest and smallest perimeter for rectangles of a fixed area. So we're just going to say that the area will stay the same, but the perimeter is what's going to be changing. Understand that the perimeter in the rectangles with fixed area can vary considerably, so they'll definitely change. And of course, to continue to develop facility using formulas for finding perimeter and area of a rectangle, and to continue to develop conceptual understanding of area and perimeter. These are things that we're going to be covering, things to make sure we understand terms. When we refer to dimensions, we refer to things like length and width. These are things we need to understand. If the term ever was used, that's what it means. And then, of course, the fixed area means that the area doesn't change. So the area will not change. Or when the area does not change, the perimeter will stay the same. Or the perimeter will change. Yeah, so when the area does not change, the perimeter will. Alright, so moving forward, here's some examples of a fixed area. Wondering, well, what's a fixed area? I'm kind of confused about it. Well, here we'll kind of walk you through what's going on. So, if we had a fixed area, say the dimensions are 1 by 12 meters. Now our goal here is to have 12 square meters. That means that the area has to be 12. Length times width has to equal 12. So 1 times 12, well, that equals to 12. So that's good. Well, what about here? What's another way we can do this? All right, 2 times 6. That's a good method. 2 times 6, those both go into 12. So the area is going to equal to 12. We have to have the same area. Okay, so what's another one we can do? 3 times 4. That's a good dimension. Now notice here, when it talks about the fixed area, the area is going to stay the same. So 1 times 12 is 12. 2 times 6 is going to be 12. 3 times 4 is going to be 12. And I'm going to do something that may confuse some of you guys. 4 times 3 is going to also equal to 12. And you're going to say, well, wait a minute, Mr. Tajik, this is exactly the same exact square, or rectangle, excuse me, as this other one. Well, think about it again. 3 times 4, length times width. It's over here, 3 times 4. Well, now this is 4 times 3, length times width. 4 is first. It's a different figure, even though it might be a little rotated, it is a different one. So just keep that in mind. There's 6 times 2, and then which equals also 12. I'm just putting the area in here. There will be dimensions that should go with these. I'm just doing this really quick. And then there's 12 times and 1. So looking at all 4 different figures, or 6 different figures, you see that they all equal to 12 in dimensions. I'm sorry, all equal to 12 in the area. But notice this, the perimeter is going to change. So the area for this first one, you know very well that it's going to be equal to 12. Meters squared. That was our goal. Good, we got that. Perimeter now is 12 plus 1 is 13 plus 12 again is 25 plus 1 again. That perimeter is going to equal to 26. Alright, no big deal. That makes sense, Mr. Tajik. That's the perimeter. Okay, well, see how it changes here? Again, we got 12 as our goal. Equals 12. area equals to 12. And 6 plus 2 or 2 plus 6 is 12. Plus, I'm sorry, 6 plus 2 is 8. 8 plus 2 on this side here is 10. 10 plus 6 is 16. So perimeter changes. And that's exactly what we predicted. So 16, bad Mr. Tajik, not putting his labels. 16. Now, if you continue to go around here, you'll see that they'll be different, except for the pairs. So that's our hope and our goal. And you see that the perimeter changes, but the area stays the same. Now, something I need to point out and make sure you recognize this. What do you notice about the dimensions? The 1 and the 12, the 2 and the 6, 3 and 4. What do they all have in common? They all have in common is they are all factors of 12. If they all multiply or could be multiplied to get into 12, they all go into 12. 1 goes into 12, 2 goes into 12. Notice that. That's very important when it comes to dimensions and finding the area. So that's just something you make sure you realize. So if we put this into a table here and do length times width for the first one, so and this is what I want to see before or as we go into class. We'll do the first one together, but I want you to complete this chart. So length is going to be 1 and 12 is our width for the first figure. Alright, now notice this. Our area is going to be length times width, which is going to be meters squared. 12 meters squared. We found all of these to be the same area. So this should be all the same. So I just did your area part or your area section for you. But notice when it comes to a fixed area, it's very important that that is something you do. It's fixed, so it's the same all the way through. But now our next target is to try to find the perimeter. Okay. A common mistake would be to just add 12 plus 1 to make 13. Well, I'm going to tell you right now that you got to be careful when that happens. Its perimeter is going to be 1 plus 12, which is 13, plus 1, which is 14. 14 plus 12 is going to be 26. So you have to do every side when it comes to perimeter. So 26 is going to be our perimeter. Alright, I want you to fill this out by the beginning of class, and thank you very much for watching.